Or a letter. Well, I was gonna stay with the other one.
Yeah. It's better to do, for real, I think it's better to do in-person classes because that way you have a relationship with the professor.
No, the professor is blended. There are some people that take it online, but those who come to the class, they also can take they also need to take the test.
Yeah, that's good.
And they are on Proctor.
Because if it's blended, it's so light that you're gonna go.
I mean, but calculus, what you just learn it. You don't have to like go to class.
No, but if you are like forced to do a test in person, you're gonna learn, because the other way. I took him, and I was like, fuck.
For what class?
1 and 2.
Calculus one.
I stayed for the second one
What's that?
because it was like.
I was gonna ask you.
friends.
Do you know where is this
Yeah.
office?
And the exams are.
Downstairs.
But now I took calculus 3 in person.
In this
That's
building.
fucking hard because
So
the
Basically,
basic stuff like derivatives.
That way, just go down one level,
That's
all
like
the way
basics.
down
Those
that way, and to the
are
left.
application.
You had
Okay,
A's.
thank you.
Yeah.
I'll be right back.
Now what do you have?
All A in everything.
What do you have now?
Now I'm struggling for the A. Struggling. First time. ¿Hola?
Lo cheque y subo otra.
Okay.
So I don't
So you missed the practice.
Man,
You could have practiced more.
it forces you to learn, actually. Because
Yeah.
it's like you need to prepare for the test.
That's good.
Who
Yeah,
did
no.
you pick for your Calc 1?
What?
Who do you recommend me to pick for Calc 1?
Calc 1, I took it with Carmes, but Carmes likes me, so like he gives me special attention for that. So like, I mean, the thing is that like he's almost like private professor for me, so.
Oh, you live here in North Campus, right? You come here.
Was it?
Yes.
Yeah, you're here.
Oh, you're in West.
No, I didn't do my plans.
But you went to West Campus, didn't you?
Because I mostly go there because the turbine. It's like 20 minutes. And I drive super fast.
Yeah.
And I have been here.
I come from Coral Springs, so I come from buttfuck nowhere.
If you're saying I'm gonna pass the class because the professor is not challenging enough, and then when I get an actual challenging professor, I'm not gonna pass that.
It's not that you're not gonna pass. It's that you're gonna be lacking. It's like, I don't know, maybe you're gonna take like linear algebra.
No, I got you. Yeah, it's better to take challenging classes while you're like going up the ladder and not take all challenges.
Especially that, because that's so basic. Calculus 1.
Right, like slowly.
It's so basic. If you're telling me, oh, okay, I'm gonna take a super tough class virtually because that's like super specific and I don't care so much. But
Yeah, like.
well, calculus 1 is so broad. It's so specific. So it's so broad.
Wait, can you give me her name? Is it
Laura,
like
the one on which one? The other option. That professor.
Laura?
Yeah.
Laura what?
Galindo.
Galindo.
Is the only two professors that teach calculus? Those two
There's only 2?
in West Camp.
Hey, come closer.
Oh wow.
Come closer here. No, here. Talk.
Hello. What's up? Are we live? Or what?
Yeah.
I was gonna say
I'm testing the.
a bad word.
Okay. Yeah, sounds good. All right. We're gonna. Woo! Okay, there you go. Mauricio, he's gonna.
Are you recording the audience, man? Don't record the
No, it records automatically on YouTube.
Hey, claps.
There you go.
Okay. Can you sit here? So it's like center.
There you go.
Just imagine you're in the Harvard
Yeah, because it's not
class
really
right
like
now.
one of these special. Now it's like
You learn. Oh.
to the audience.
Yeah, do it.
Alright.
I'm gonna-
I'm gonna do like a 1, 2, but you need to stay.
Oh yeah, okay, cool. Yeah. All right, cool. Yeah, I'll do it for you.
Okay. What are you doing?
I just was clicking there. Okay.
Okay. 1, 2, 3. Good morning, everyone. Good afternoon. I'm gonna present to you guys the project that I did on summer of 2022. And what is special about this presentation is that I was just beginning to learn how to program. I started this project with zero experience at all programming. and I was able to do this project and also other one. But this one is one that makes me really proud. So let's start the presentation. So this, as you guys saw, it was the project was automating a process of photolithography. Photolithography, in this case, is using light to do certain stuff. For example, they used it to create the circuits, and in this case, we used it to basically create these shapes with gel. And why automating? Because this process was done manually by the professor. The professor, for example, to write the word, the FIU, it took him like 2 weeks to write something like that. And thanks to the project that I just did, it allowed him to reduce the time by 1 hour, something like that. Because these shapes are microscopic, and it's difficult to maneuver the microscope. And well, continue. So the hardware for the process was the microscope and the motorized stage specifically. That's important because that was the thing that I used to program so that it moved and created a shape. Also the container that you can see here that had the fluid. This is a microfluidic device. And in that device we put the gel that when it was in contact with a dosage of light, it made the gel solidify, basically. And that was the goal of the project. That was the hardware. The software that I created was something like this, where I would, for example, create this shape and then draw it by clicking some squares of a grid, and it will basically move. For example, in this case, it will move first to the left, so like this, then down. I create a shape like that. I think that you can play this. This is a video. Continue.
You continue? Okay.
Some of the biggest tasks for the project was the serial communication, for example. Serial communication is like USBs or like printers that connect to the computer. It's how you send basically information to the microscope stage. It was really something completely new for me and so very super interesting because it allowed me to, for the first time ever, send commands to something and make it move. It was super interesting. Also, converting the click grid cells into coordinates. So as I told you, I created a grid with a bunch of squares, and as I clicked them, they were then behind that was a matrix that represented a coordinate plane, and that then translated into movement of the microscope. After I clicked on a specific coordinate, I send that command to the microscope and it moved. And I send it to serial communication. Another important step was controlling scales and dimensions of the light beam, the container, and the change of position. The light beam is with different lenses, and as we increase the magnification, it gets smaller. And it's important to understand the scale of the light beam because that allows me to understand the width and the detail that I can use to create the shape. And it also dictated the smallest unit of the container. The container was also important because I had to then make the program, for example, based on the light beam. I created just a square of the grid that I created that you're gonna see in the slides after this. And based on the container, it's like the total amount of squares that I can fit in the drawing, on the interface. And the change of position, that's regarding the dosage, the light dosage, because I can pass through the gel with the light, but it's not immediate. It takes some time to solidify the gel, So that's something experimental. I needed to understand the acceleration, the velocity, so that I could give the appropriate dosage to the gel. And also baud rate stability is basically just to send the baud rate. It has to do with serial communication. Baud rate is like sending more information, and sometimes the programs crash because of some missteps. So that was important, something that as I told you, I didn't have experience. And at first the program was super slow, it processed super slow, and then I made it faster thanks to some tests that I did. Alright, videos of the prototype. Can you please?
Isn't it on the outside?
Wait, there must be a way that I'm not doing
It's on
this.
the outside. Right there.
Here?
I have no idea. There's always a solution.
Yeah, there must be. Oh,
Right there, yeah.
I've been working on improving the program. This was on July. Now and I did it on Python. And you can see the interface. It was just at the beginning, the interface didn't have any specific dimension. It was just the beginning steps of the project. After I click those cells, you can see that they are being recorded here, and they are going to be read and then move the microscope, basically. This is in Python.
what? Real quick, what library did you use for that? That's important. Remember that?
Oh yeah, well, there's this grid it was a library. It's called Pygame. Pygame is a Python library for games. It's really useful for clicking stuff, for buttons, and it allowed me to very easily create that grid.
Well, it's a good thing about that too that I saw, because I didn't get too much into that library too. I went a little bit through it with you, but the interesting thing about games, and that's something that we're working on with some other projects here in the robotics program. Making games or game interfaces is a great way for simulate things in the real world too. So for example, you have a gyroscope, you make a game simulated version of a gyroscope, right? Like just basically a thing that moves around basically in a game. But instead of giving it like you would say a game that you give controls with your inputs, you give it control with the inputs from the gyroscope, and that allows you to see a simulated version of the gyroscope. That's something that we're working on right now. So this like Pygames and like games is very useful to learn to program the games, because they allow you to do like real-time interfaces that are very good, especially for robots. It's actually very, very useful. So just so you know, because it's Pygame, and like the thing is that it being game libraries is actually, I think, something good to showcase. So it's good. Yeah.
Now let's see the other one. Now you're gonna see the microscope stage move. It didn't have the container of with the gel.
Oh, sorry. Släppen oss av.
It's moving the microscope stage with the same, following what I drew previously by clicking. It doesn't have the container in this video, but because this was the beginning stages of the project. After the program is completed, this one is from the report.
Also, because it's microscopic, you cannot really see the machine doing some big movements, right?
It
it does very small movements.
That's something important about the controlling scales. How big do I do the movement? For example, if one of those squares, how much length does it represent? That's something that I mentioned previously, and now you could see it. Now
I think you show it more in another. I think.
Okay.
This is it.
Now, now this is about the light beam. when you take a picture of the light beam and you plot it in 3 dimensions based on the intensity, it's gonna get something like this, that the intensity is highest on the middle, and then you cut it, do a cross section to understand the width. This is called full width at half maximum. And this allowed me to get, in theory, what was the size of the square, each square. Because that's, as you guys see, the thinnest possible line created by my drawing is dictated by this amount. After I got the amount, the full width in pixels, I took a picture of a scale, and this is a, I think, 1 centimeter scale, and in the 1 centimeter, in a section of it, like 0.6 millimeters, there were 1800 pixels, and then I did a conversion so that I could understand how many pixels of this represent a length.
So yeah, that's just to add to that too. The super important thing, again, you're transforming basically real life measurements into basically like a game interface, so you can interact with them, right? So the cool thing about that, I know we talked about that for like a long time when you were working on that. So yeah, the interesting thing is that you can have like that measurement, right? Like you can have like the measurement that says that this is what the light beam looks like, right? But you need to have a way to pair it with something in the real world, because remember that first time you brought it, he brought that thing, he brought it to us, and he was like, okay, how much is this? But the thing is that we didn't have a way. We knew what the pixels were, right? We knew that this was this many pixels, and we knew that that was the light beam, and we know that it was a very small thing. But what we didn't know is that, like, okay, I know that those pixels are there, but where is a real photo? Like, I needed and this when you went and did the other thing. That's something very important to understand, to like know, is that you are gonna need not only the measurement in numbers, you're gonna need what those numbers translate to in the real world. So that's what the other thing was for. Was an actual ruler. Basically, you put a ruler that tells you, okay, this is what 1 centimeter is, and then you basically you gotta count it, you gotta see it, and that then you can use to put in your as a cell. Like that measurement becomes a cell in the game, and the painting of those cells is what translates it. So but yeah.
Exactly.
Okay.
All right, you can see more closely. Basically, as I click, for example, a cell, it translated into, for example, this one. What was the last one? Maybe it's here on the top and you cannot see it, but this one would be 1 0, so 2 0, 3 0, blah, 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 blah. The interesting thing is that I had to deal as well with reality. That in the perfect world, you're gonna see it in later slides, this super 90 degrees interface in the perfect world will translate into, will work along a perfectly 90 degree aligned container, but it wasn't like that. For example, because it's microscopic and it's misaligned. So I had to go to trigonometry, did some research, and then basically rotate every point based on an inclination. For example, if I say that the container, look, let's go to other slides. Oh,
Is it a farther one?
Yeah, it is.
There you go. Yeah,
There it is. So if I
that's
go,
very interesting.
yeah, this is the perfect world scenario. These are aligned, but in reality, it's like this. And I realized this after I was doing it. I was like, wait a minute. There's gonna be a misalignment. And these are all questions that I had to answer myself, because the professor gave me a lot of independence to work on the project. It was an internship, and I was trying to do my best, trying to do the best I could. So how I solved it? One solution that I thought was going to be possible, but it was a very tedious and complex process, was to create some lines, and then the intersection of the lines were going to give me points. But then I realized that thanks to some trigonometry, I could just come to one corner, go move a little bit to another portion, understand where they are, and that is going to give me an inclination. And based on this slope, I'm going to rotate every point based on the difference with the x-axis. That's going to give me a reference to rotate every point, so that if I click here, for example, every point is going to be rotated here. This represents the virtual world and the real world. Next one.
Do you want to talk about this or what is that? Oh, no,
No,
doesn't
let's go to the next one. So this is the process. What I did, this is not the container, but because I didn't have the container back then on July, but the process is similar. You come to a corner of the container, in this case the ruler, mark one point, and move to the other point. You guys can barely see it, but it is. I moved super straight, and it was different. I arrived to, because I put that ruler myself as best as I could, but that's microscopic, and it was misaligned. So then I go a little bit down. I mark. You cannot see it here, but I go down so that I are more or less in the same position. Because here I'm
go
on
down
top
on
of
what?
the
Sorry.
black line. What?
Go down on what? Using the machine?
The microscope.
Yeah.
Because this is like, if I had this point and then I move and I arrive like exactly here below the black line, it will be great. The inclination will be 0. But in this case, I'm a little on top of the line, so I had to then move down and mark where that position is, and then with those 2 points, I created the angle, and then I rotated every point. It was amazing seeing it happen. That's all programming. I had to program how to rotate every point. As you solve problems and things work, it's amazing. Next one. Okay, let's go back a little bit before to the one about the light intensity. This one. As I was telling you guys, this is the intensity. I then did a cross section of it, and I obtained the full width at half maximum that gave me a certain amount of pixels. In this case, for this one, the 10 times magnified objective lens, it was 336 pixels, and this is how the image looks from the top. And the main goal was to, as I told you, understand the smallest units possible for the interface.
Then you translated that with a ruler, right?
Exactly.
Yeah.
Okay, so these are some of the testing. And as you guys can see here, on August 15, these were the shapes that were created. We were using a line width of 200 micrometers, and that's, if I'm not mistaken, that's the 10 times magnified objective lens. And I'm moving basically at a certain speed here for this L, then faster here, faster, and I go faster. And you can tell that this portion was very poorly solidified. And then you can see days after that they were, for example, they were gone, and the remaining that were properly solidified were these ones, because I basically moved slower. And this is, as I told you, regarding the light dosage, because the light beam is below the container with the gel, and it takes some time to solidify it all the way to the top. That's what you're seeing here. And compared to this is more solidified than that. And after 2 days, it washed away. These are air bubbles. Champagne. When you're working with microfluidics, air bubbles is a pain.
Interesting.
And now you're gonna see one with a thinner width. This is the 100 micrometer width and the same size. The previous one is here, and then I moved over here. This was just testing, just testing the solidification and the program that it worked. And you can see that as the lines get thinner, the intensity of the light decreases and almost nothing was solidified after a few days. It looked like it was, but after a few days, the top wasn't properly solidified and it washed away. And this is, of course, a unsuccessful solidification, but it's a test of the interface and that it was working properly.
Mm.
Next one. Now we are encountering another problem. Let's go back. You cannot see it here, but what is happening is that at the beginning the microscope is moving. You need to read the manual if you're working with something that someone else built. In this case, I was working with a microscope stage controller, and it had a preset. It's called backlash, and before every movement, it moved to the left. But when you're working with this width, you're gonna notice it. But then with the thinner, in this case 20 microns. So the other ones were 200 microns, 100 microns. This is 20 microns, and this is 0.5 millimeters. The other one was 2 millimeters. So if you go, let's go back. This is actually here on the top. You guys can see. So you guys can see how smaller it is compared to this big stuff. It's here on the top right corner.
Oh, I didn't realize that. Okay.
Yeah. So let's go. So this was a mistake, of course, because I wasn't expecting to encounter this behavior, and I wasn't seeing it with the bigger scale. Then I went to the smallest scale possible, one of the smallest ones, and I encountered this. It was a super easy fix, but it was a surprise that I encountered, and that's thanks to the testing. That it didn't happen in reality with, I don't know, that I didn't, for example, gave this to the professor as a final product with that mistake. I was able to fix it thanks to the testing. And you guys can see that it's moving.
I didn't know you already fixed that, but that's cool.
Yeah, this is fixed.
What was the fix?
The fix was setting the backlash to 0. It's moving. It was just a preset. It was just a preset. So let's.
Interesting. Oh, okay.
And now I'm working with MATLAB. I have been working with.
I didn't do that.
I'm working with MATLAB.
The thing is, when this video ends, the presentation ends. So I think it should be fine.
The thing with Python is that yes, it's very useful, but it's very useful, and it was very simple for me to learn at the beginning. As I told you, I started this with zero knowledge about programming, and I googled what are the easiest programming languages. Python. What's the simplest? Python. Applications, Python. So I went with Python, and then the professor, he's experienced with MATLAB, and a lot of scientists and engineers are experienced with MATLAB, and this is a tool that he has to use. I am going to leave, and I'm going to leave him the tool. So he asked me if I could do it on MATLAB, and I was like, no, professor, it's hard. But then, after the project was moving along, I realized that I had to do it on MATLAB if I wanted to leave something behind meaningful for the professor. If not, if he wanted to modify it, it was going to be very difficult because he's not experienced with Python, but he is with MATLAB. So this is how more or less the interface looked back then in September, while I was working on MATLAB. Something similar. It doesn't look like this. Now it's even better, but I don't have a video here to show. And as a conclusion, I could tell you guys that it's one of the best ways to learn to have a super introduction to what is programming, what's robotics about, is to start with a project and just Google examples like how to do this, and put the pieces together as I did. I Googled a lot, and for example, on MATLAB and also on Python, reading the libraries and reading how people solve previous problems, then you can apply that knowledge into your project. For example, how to create a grid. It's a for loop, or this in this case is a different thing. But stuff like that Googling and introducing yourself to programming like that, I think it's one of the best ways, because, for example, as you guys saw, I was able to go into a lot of aspects about programming, like translating real stuff into the virtual world, and also how to communicate with a computer, because this is not just the interface, this is also sending commands to the microscope so that it moves. That's something that I, just by learning how to program, you don't have the experience. But then working with hardware in a project like this, it was amazing. You guys can do it with like Arduino or stuff like that, with a car. And as a conclusion, I can say that it was a very good opportunity for me to learn how to program. The expectations, you guys, I didn't mention this, but the expectations with the professor, I told him, honestly, professor, I don't have much experience. What are your expectations? Do you want me to finish the project, or is it okay if I just make some progress in the project? And he told me, yeah, I understand, you can just do some progress. And I thankfully can say that I surpassed the expectations, because this is not working and the professor is gonna use it. So it's great having this opportunity, and also having people on the robotics club. If you have a project, people on the robotics club know a lot, and they can help you out. There's now new people that know a lot, and you're going to get help from us. It's a good environment to be a part of.
Tell me what I told you. You remember what I told you?
What?
When you called me? He gave me when he got that offer, he gave me a call.
Yeah, I called a few people because I didn't have any experience. I wanted to get into a project. I applied. I didn't know if I was going to get in, and I got in because the professor read in my essay that I wanted to automate some stuff. I wanted to work with robotics, and he had this project available. And I was like, okay, what are the expectations, man? Because I don't know how to program. Is this even possible for me to do something like that? I explained the project to Felipe briefly. I explained it to Jonathan Pearson as well, and to other people, and they told me, yeah, man, give it a go. Give it a go. If the expectation are just to make a progress, you're going to do it, and we're going to help you here in the robotics club. So join the robotics club to do a project like this.
Yeah, it's good. It's good stuff. That was good. What I remember telling you is that what is gonna be a piece of shit, and you're gonna suffer, right? It's gonna be hard, and but that's good. That something is hard, is that what you're gonna do is probably gonna be what's best for you. Doing that, getting into the hardcore stuff without knowing and things like that. That's gonna give you the burst learning experience. And I hope that you say that you like that. So that's
yeah,
good.
man, that's amazing. Now you cannot see it, but now the program is improved, and the professor, one of the applications that he's going to give is to create, for example, I didn't explain this, but some application is that you can create, for example, in the petri dish in biology, if you put some cells to grow, they're going to grow in any direction. But if you create that structure with the gel, you can force the cells to go in a specific direction. And you guys saw how small I can work, how the scales are super small. I can go even smaller than this. So that's the application that the professor is going to give it. Other people give it some other applications, like creating, putting gold on the gel, and with light heating up the gold and contracting it and moving stuff. That's another interesting application that I didn't do, but I did this one, and it was still super great. So yeah, join the robotics club.
Nice. That was good. All right, that was amazing, guys. Thank you so much, Mauricio. That's very good. Cool stuff.